My name is Theodore DeGuzman. I am a mechanical engineering student at Johns Hopkins University, and my expected graduation year is 2024. Today I will be presenting my freshman fall design project for mechanical engineering design in CAD and mechanical engineering freshman lab 1. I collaborated with William Legere and James Kaluna on this project in a virtual setting. The objective of this project was to catch an egg drop from a distance of 1 inch, transport the egg horizontally 6 inches and up 2 inches, and release the egg in a controlled manner. Every device must be entirely mechanical with no electronics and fit within a 1 cubic foot box. The device must also be sturdy and stable, and the egg cannot roll as it is transported. After several iterations, I came up with a final, reliable product. The device was primarily made out of 3/16 and 1/2 inch plywood that I cut out with a jigsaw, wooden dowels, and radial bearings. I later created a SolidWorks model in order to more clearly explain how the device works. The wood was all purchased from the Home Depot and cut out using a jigsaw from hand drawings. The bearings were purchased from a skateboard store, and the weights took the form of 50-cent penny rolls. All the components were fastened using superglue. In order to get a better idea of how this project works, we're going to use a section view. As the cradle catches the egg, it lowers due to the added weight. The cradle is connected to the hammer by a string, so the hammer begins to lower as well. At this point, the hammer contacts the egg, forcing it into the chamber. At the moment the hammer becomes vertical, it loses contact with the rotation drum, which it was preventing from rotating. Therefore, the weights on the rotation drum are now free to spin. The chamber is now at the top of the device, and the egg is able to slide down the inclined plane, being released. A notch on the frame stops the rotation at the correct point. One of the problems that I overcame was trying to overcomplicate and overconstrain the device, especially given the limited precision of tools available. I overcame this by revisiting the initial problem and creating a more simplified design. I also found that I need to spend more time on ideation and less time creating exact prototypes, instead opting for prototypes that exemplified the concept. As a team, we also overcame time zone barriers, learning effective communication and scheduling in order to collaborate successfully.